All right, so today we're going to be talking about area of parallelograms. And triangles. Area of parallelograms and triangles. All right, so in a parallelogram, you have two pairs of parallel sides. All right, you got a top that's parallel to the bottom, right side parallel to the left side. Parallel sides are called bases. So what you have here is a parallelogram, but since both pairs of parallel sides, because both pairs of sides are parallel, every side is a base, okay? What's important, the height is perpendicular to the base. The height is perpendicular to the base. In this case, if we drop this in right here, this dimension, and we say that that hash line is perpendicular to this base, then this is the height. That same height could be over here, right? Sometimes it's given outside the shape. This could also be the height. Let's draw another one of these. Now, if you're given this dimension, let's put it right here. Where's a good place to put it? Right here. See it? See, this dimension now is perpendicular to the right side of this shape. That makes this a base, and it makes this perpendicular to the base, the height. Everybody see that? Base perpendicular to the height. Base perpendicular to the height. Ooh, I didn't spell that right. Para is equal to base times height. All right, your area is equal to the base times the height. So let's find the area of this parallelogram. Tell me when. Good right there? All right. Let's draw this parallelogram. Now, this is kind of what you got to be careful of in these parallelograms. You've got this parallelogram here. Let's call it ABCD. Do you see this dimension right here? What's this called? There's your height, isn't it? But which base are you going to use? Are you going to use the 4 or are you going to use the 10? Let's do this. What's the length of side AB? What's the length of side BC? You've identified the 5 as the height. So if the 5 is the height, aren't the base and the height perpendicular? So what side is the height perpendicular to? It's very good. It's perpendicular to the 10. All right? So here's your base. And this is the height that you have to use. You can't use the 4, can you? All right? Because the 5, which represents the height, is not perpendicular to the side that's 4 units long, is it? It's perpendicular to the side that's 10 units long. So this is a tough one here. The area equals base times height. Can anybody do that without taking their shoes off? What is it? 50, good. My honors class, right there. 5 times 10, 50. Did you get that, Deja? Yeah. That a girl. Proud of you. That's so much fun. We're going to do it again. Let's do it on this one right here. What'd you say? Isn't this fun? Aren't you glad you came back? Doing what? Oh, I will. Look at Deja with it. She sucked her teeth. She said, why'd you say so? This is bullying. All right, so look what's going on here. You got, what's this whole bottom side? This whole thing, well, look. Thank you. This whole top, that whole top's 21, so the whole bottom is 21. And doesn't this represent the height? But it doesn't have a dimension, does it? But what kind of triangle is this? Good, it's a right triangle. And this is your height. So isn't a leg squared plus a leg squared equal to the hypotenuse squared in a right triangle? Good. So your h squared plus your 8 squared equals your 12 squared. So if you subtract 8 squared from each side, then h squared equals, you can do that in your calculator. Type 12x squared minus 8x squared. 12x squared minus 8x squared equals, my calculator says 80. And then if you find the square root of both sides, you get 8.94. Now, you're not done, are you? No, that's just your height. So we got to find the area. So the area right here equals the base times the height. So that 8.94 is still in your, no, it's not. Let me square root it. I got it now, and I push times 21, I push equals, and I get 187.8. Everybody okay with that? Very good, very good, very good. That was so much fun. We're gonna do it again. Now look what, let's see. This is, I like this. This is fun. Now we're gonna do a little more, get a little deeper into this height here. They just start giving you more and more clues. This is 8.5. This whole dimension looks to be 15. Now, this is our height, right? Because it's perpendicular to the side that's 15. So here's our height. You see this 45-degree angle? What kind of triangle is this right here? What kind of triangle is this red triangle right here? Isn't it a 45, 45, 90 right triangle? Remember special right triangles? Isn't the height the leg of this 45, 45 special right triangle? Anybody remember the relationship between the hypotenuse and the leg of a 45, 45, 90? Exactly right. H times the square root of 2 equals the 8.5, right? So if H times the square root of 2 equals 8.5, how can you find the H? What if you divide both sides by the square root of 2? Won't that cancel and leave the H by itself? So in your calculator, 8.5 divided by 2 square root equals 6.01. So that's our height. So now we've got our base and we've got our height. So our area is going to be equal to 15 times 6.01. And I get 90.1, 90.2. Everybody okay with that? Now, here's a higher order thinking question for you high order thinkers. If the first problem we did, you were given the base and the height, right? Second problem you did, you had to find the height using what? What's that formula called right here? Pythagorean theorem. Then you had to find the height using what kind of a triangle? A 45, 45, 90 special right triangle. What do you think the next question is going to have you do? Two good answers. Now they're going to make you find the height from a 30, 60, 90 special right triangle. And then probably finally they're going to have you find the height when they give you the area and the base. Right? And in that case, you just divide the area by the base. Agreed? Whatever's left is your height. So let's do one more of these where we got to use a 30, 60, 90. All right, so we got this here. And we got a 30 in there. And now we got a 32 across the top. And I can't even read what this book says. I'm going to make this 12. I think my eyes got worse over the break because I got older. And, yep, that's all they're giving us. So, got a 30, 60, 90 right triangle. The other special right triangle. Does anybody remember the relationship between the short leg and the long leg? Right? Got a boy. The relationship looked like this in a 30, 60, 90. Here's the kind of a shortcut. If this is your 30 and this is x, this is 2 times x, and this is x times the square root of 3. Okay? So 12 times the square root of 3 is your height. What's your hypotenuse equal to right here? This right side? 24. So the area of this parallelogram is equal to the base. What are we using as a base? Be careful. That's right. Yeah, be careful. We're using this dimension. All right, be careful not to use that 12. The area is equal to 32 times 12 radical 3. And that's 32 times 12 times 3 square root button. And that's 665. Everybody all right with the area of a parallelogram? Area of parallelograms? Very good, very good. All right, let's do area of a triangle. Area of a triangle is equal to 1/2 the product of the base and height. All right, the area of a triangle is equal to 0.5 times the base times the height. Because every triangle is just half of a parallelogram, isn't it? So base times height is the area of a parallelogram. If you multiply it by 0.5, you take half of it. So in your triangle, same rule applies to your base and your height. Here's your base. Here's your height. Base and height are always perpendicular. They're always perpendicular. And look, if you had this triangle, let's put it over here, something like this. You could find the height out here as well. All right, now this is your base, and this is your height. The height doesn't always have to be inside the triangle. It just has to be the length of a segment perpendicular to the base. Perpendicular to the base. All right, so we've done a couple of area of triangles this year, haven't we? So let's do this. Let's do an example first of the area, and then we're going to do an example of a problem where you need to find the height. So let's take a look at this triangle right here. We've got a 19. Now we've got this dimension. This is 30. 41. And this is 27. Find the perimeter. Oh, find the perimeter and the area. Okay. So we got to find the perimeter and the area. Let's do the area first. Area is equal to 0.5 times the base. What's the base of this triangle here? 19. And what's the height? Does everybody see that the height is 30? Okay. Here's our base. Here's the segment perpendicular to the base. It's way outside of the triangle, but there's your height. So 0.5 times 19 times 30, what's that equal? Anybody? What'd you get? 285. So there's your area. Now you need the perimeter, but look what you've got this side of the perimeter, don't you? You got the 19. You've got the 41. Aren't you missing a side? I'm going to call it X. Isn't that side the hypotenuse of this other right triangle here? So to find that, we would use the Pythagorean theorem again. 27 squared plus 30 squared equals our side X squared. So now this is pretty simple to do in your calculator if you're getting used to using some of these other functions. You can type 27x squared plus 30x squared and hit equals. 1629 equals x squared. And then while that number is sitting on your screen, you can push the square root button. So 40.36 is equal to x. All right, we got that by square rooting both sides. All right, so in that case, we found the area and the perimeter. No, we didn't. We haven't even found the perimeter yet. The perimeter, what's the perimeter equal to? 19 plus 41 plus 40.36. And that's 100.36. So our perimeter equals 100.36. Perimeter and area. Any questions there? All right, let's do one more example working with these triangles. Let's say on this triangle that the area is equal to 148 square meters. Let's say that this is our triangle. You got to find H. So the best way to do these is to write out the formula for area first. Area of a triangle equals 0.5 times the base times the height. And then substitute all the information that's given. You've got the area, you've got the base. So your area is 148 equals 0.5 times your base, which is 34, times your height. And now do your math. All right, take your 0.5 times 34. So you get 148 equals 17H. And then you can divide both sides by 17. And I got 8.7. So 8.7 is your height here. Good? Questions? Please do both of these steps when you're doing these type of problems. First step being to write out the formula for the area of the shape that you're working with. Second step being to substitute the given information. All right. Once you get that on paper, sometimes if there was any confusion about how to do the problem, getting that much of it on paper will clear up the confusion. All right, so what was that? The beginning of chapter 11. So here's your practice for today. Page 139 and 140. All problems You're doing all the problems. When you're done, when the bell rings, you're going to go, let's see, this is going in the basket. Or you're going to email me a picture of your work. And when you email me that picture, it should be within the next, when does the bell ring? 1:53? Yes. In the basket, or email a picture at 1:53 today. I'm tired of you guys at home emailing me pictures 2 weeks after I gave the assignment. I ain't accepting it. It's due today at the end of the period. Everybody understand that? You guys that are at home, you're excused from this meeting to complete your assignment and take a picture of it and turn it in. You've got plenty of time to do the 10 and to do 20 problems. Plenty of time to do the 20 problems that are assigned. So get them done, get your picture turned in. Are there any questions from you people at home? If not, you're excused at this time.